Good afternoon, everybody. Welcome to the CDCP sneak peek provided by EPI. My name is Marco van Gink. I hope you're all having a pleasant day, and in the next 45 minutes I'm going to talk you through the CDCP highlights. And if you have any questions about this, I've already listed my email address, so please feel free to send me an email in case you have any questions about this sneak peek or the training program provided by EPI. My name is Marco van Gink. I'm one of the trainers from EPI. I'm based in Holland, Europe. I have 17 years of experience based on IT data centers, building, designing, redesigning, and I've operated several data centers all across Europe. Now let's see what's the agenda for today. First, we're going to do a small introduction about EPI. We're going to talk about the DC training framework. Then we're going to preview the CDCP course, Certified Data Center Professional course. This is about 25 slides. And then we talk a little bit about the data center career planning tool that EPI has released 1 year ago. After the DCCP, we are having some questions. You can ask some questions either by chat through this presentation or by email. Now, who is EPI? We are the biggest data center training company in the world. We've been founded in 1987 in England. We moved to Singapore in 1999, and we've been training many people all across the world. We have 9 EPI offices, and we provide our training program through our local partners in more than 60 countries all over the world and in more than 130 cities. So EPI is the data center expert company. We provide design evaluation and validation. So in case you're going to design a data center, or maybe you have designed a data center already, we can review your design plans and even match them to see if they are fit to be audited by the TIA 942 standard. We provide audit certification of all data centers all across the world based on the American TIA 942 standards, and we provide a very extensive training. We have a very extensive training program with multiple different training, all having a certain focus, and we'll see on the next slides what's included in this training program. Let's have a look. We have been receiving many awards in the past 30 years as well. We've been awarded by the 20 most promising data center solution provider in 2015, 2016, and 2017. And we've always been also been awarded by the 20 most innovative company to watch in 2016. Our CEO, Edward van Leen, is named in many different magazines, and he's been listed as the CEO of the month in June 2015, and we are also the official training partner for Afcom and for the data center world. So in many pages listed on the internet, you can find our company name as well, and also at LinkedIn. This is the training framework from EPI. We have 3 different scopes. We have the design build scope, which consists out of the CDCP, the CDCS, Certified Data Center Specialist Training, and also the CDCE, the Certified Data Center Expert Training. We have an operations framework, which is the CDFOM, Facility Operations Manager. We have the CDRP, the Risk Professional, the CDSM, the Safety Manager, and also the CDMS, the Migration Specialist. And the third scope will be the standards, which is the CTDC, the Certified TIA 942 Design Consultant course, where you will be trained how to design a data center purely on the TIA 942 standard. We also have the CTIA, the internal auditor course, and we have the CTEA, which is the external auditor course for the TIA 942 standard. Today we focus on the CDCP, which is a Certified Data Center Professional. This is a 2-day course. It's being given all across the world in many different times, many times during the whole year, and this is a 2-day course. If you pass for the CDCP, you can register for the CDCS, which is a 3-day course, and then eventually you can sign in for the CDCP, which is a 5-day course. Now let's have a look at the CDCP Certified Data Center Professional. This will be the agenda for the course. As I just mentioned, this is a 2-day course, and this is basically a very comprehensive course. It's an overall course. We talk about many different aspects of the data center and of operating a data center to give you a better understanding about what's involved in running a data center and what are also the possible risks in running a data center. On the first day, we have the data center standard that we will be referring to, which is the TIA 942 standard. We talk about the different constructions of the buildings with the pros and cons. We talk about raised floor systems, electromagnetic fields. We talk about cooling infrastructure. We talk about fire protection and safety, security and safety, and also cleaning the data center. How do we clean the data center? And at the end of the second day, you can actually proceed with the exam, which will be checked by EXIN, and this is an exam that you should be able to pass after following the CDCP course. Now, what's involved in this course? This is one of the slides in the course mentioning the data centers and the foundation of every organization. And as we might know, the data center is one of the most important parts in running the business, because if part of the data center becomes unavailable, or maybe even the whole data center becomes unavailable, this will cause impact to your main business. And in many cases, people don't know what is the cost of downtime. How much money would it cost in case the data center becomes unavailable for 1 hour, 1 day, or even 5 minutes? And in order to design a data center properly, we always have to ask ourselves, what's the cost of downtime and what's the amount of redundancy that we want to design, that we want to build. Now, the complexity of data centers obviously consists out of many different facilities that we need to have in order to operate the data center. And one of them will be the power distribution, which is the power transformer, but also the emergency backup power, being a diesel generator, for example. Also, the UPS system is very important. That consists of multiple batteries, and in case there is a mains failure, a power failure, then the servers should be able to should keep running based on battery power. We talk about the different methods of power distribution by regular power cabling or maybe even busbar trunking system. We talk about access control, biometric access control, for example. We talk about water leak detection, cooling systems, fire extinguishing systems, and also lights. And all of these facilities are very important, because if some of these facilities might fail, or maybe even one of the facilities, this will create impact to your availability, to the availability of your data center. Now, the bad news is there is no worldwide recognized standard. So how do we design the data center? Well, in many times that's based on best practice. Now, there is some good news. We have a semi-standard, which is the TIA 942, the Telecommunication Infrastructure Standard for Data Centers, which has been expanded a couple of years ago with facilities as well. So it does mention a lot about UPS systems, diesel generators, but also physical distance from airports, the stability of the building, construction, the telecommunications, how to set up and design your telecommunication network in order to reduce possible downtime. Now, site selection and location evaluation is definitely key. Where do we build our data center? Because if we build our data center next to a train road or to a highway or next to an airport, this will cause troubles. This might cause troubles because of vibration, contamination of the air, for example, even a risk for flooding. So we always have to find out what's the potential natural hazard. Are we installing the data center in an area which is often experiencing lightning, for example? And lightning is dangerous, because if lightning hits your building or hits somewhere near your building, then it will create a huge power peak. And this power peak might damage your IT equipment as well, or your UPS systems and so on. Flooding always is a risk as well, especially with heavy rainfall or during season changes. If we have a lot of water, then it might flood our data center. Now, a typhoon is obviously very important. If we are installing a data center in an area that is a little bit risky for a typhoon, then obviously this will create a lot of damage, but also forest fires. And think about the contamination that's being caused when the forest is in fire. Basically, it's a lot of air contamination, and this might end up inside the data center. Now, potential man-made hazards. According to the TIA, we should install our data center a certain distance away from the airport, but also a certain distance away from tunnels and lakes. The train airport we should stay away from because of vibration, and also radio frequency towers because of electromagnetic fields. Industrial pollution, obviously in the heavy industry, that's definitely a spot that we want to stay away from. And this is all being discussed and being listed in the CDCP in much detail, because this is very important. Site selection is key. Also, proximity evaluation to emergency services. Should we be installing a data center next to a fire station, for example, or next to a medical facility? Well, that could mean troubles as well. Proximity to the neighborhood, where people are living in an urban area. How about the sound of your diesel generator? What about the noise of your cooling system standing at your rooftops? This might cause issues. And then any proximity to high-risk targets such as embassies, government buildings, television stations. We should definitely keep an eye out, and we should think about whether we want to install a data center close to those high-risk targets or not. So convenience should not overrule security, obviously. It's quite easy to enter the building easily, but security is key. Now, in the CDCP, we have many different slides about the load factors as well, because in the past we were using server racks which had a UDL load. So basically, the base of the server rack was standing on top of your raised floor system, and the whole weight of the rack was being equally divided over the area. Nowadays, many server racks are being provided with small feet or casters. So we end up installing the server racks on top of our raised floor system, standing on 4 small casters, wheels, or feet. And as you can see in this slide as well, loading the server rack with a weight of, let's say, 1,000 kilograms would mean that if we have 4 feet, every feet is carrying 250 kilograms each. And this is a huge point load on your raised floor tile. This might become an issue in the future as well, because in the past we only load about 500 kilograms in a rack maybe, but nowadays we see racks standing which are carrying 2,000 kilograms. So if we have 10 of those racks standing next to each other, then we can imagine that this might create a lot of stress on your raised floor system. In the CDCP, we talk about light fixtures as well. The amount of light is being expressed in a certain value. This is something that we have to remember in the CDCP. And obviously, we need to have sufficient light in order to do our job safely inside the data center. So at regular intervals, light should be located in all aisles. And there's one very important aspect on this slide as well. Those lights should not ever be connected to the IT static UPS system. And this might cause troubles in the future. And this is something that we focus on in the CDCP a lot. Now, some of the slides are talking about power generation, and also power distribution. This is a very important chapter in the CDCP, consists out of multiple slides, and we follow the route from the power based from source, as you can see at the left upper part of the slide, all the way down to your building at a certain voltage. And power obviously is key, because if we lose power to our building, and if our diesel generators or backup power are not started and not working properly, then we will suffer downtime, and then the huge cost will happen, obviously. Now, we talk about redundant options, redundancy in our power distribution network inside the data center. In this example, we have equipped, we have provided 2 UPS systems, one being spare of the other one, so we can call it an N+1, depends a little bit on the capacity. And in this case, if one UPS system fails, then the other system should continue to work. so the IT equipment should not suffer from downtime. We have many examples in the CDCP talking about redundancy as well. This is another example based on rack level, where we provide two separate power feeds to the server rack, and we connect both power feeds to a static transfer switch, which is installed at the lower part of the server rack, which is an A and a B feed, and it will create one feed to the IT equipment, both A and B. And in case the UPS A or the UPS B fails, stops working, or needs to be maintained, then still the IT equipment will be provided by power inside the rack. So this is one of the many different high availability examples that we talk about and that we list inside the CDCP course as well. Now we talk about grounding, because grounding is very important inside the data center. Grounding and earthing both the same, and obviously grounding will establish voltage references, but it will also provide a lot of safety. Think about lightning when it hits the building, then the power running through the building should be guided to the ground as well in order to protect your IT equipment, your UPS systems, and so on. So it should be able to carry lightning currents. The grounding needs to be of a certain diameter as well, and it will also provide an ESD discharge path. This is a very important chapter in the CDCP. We have some values that we have to remember as well, the highest value or the lowest value, and also what will happen in case power is being transported through the grounding wires, and what will happen to it in case it's too much, for example. We have to use a clean earth or ground for the data center equipment, and if we have any pollution sitting on the earth or the grounding spot, then we should take appropriate measures in order to get it back to a lower value. Now, talking about power quality, we have another couple of slides coming up in the CDCP, and we talk about the sinus of the power as well. And if we are using maybe cheap LED lights or older type of IT equipment or UPS systems, then harmonics or common mode noise might show up inside your electrical network inside the data center as well. And this will have an impact to your IT equipment and also to the long-term reliability. So this is something that we talk about a lot in detail, and also how to prevent harmonics, or even or how to decrease the amount of harmonics inside your electrical distribution network. Now we talk about two different types of UPS systems. In this picture we can see two different systems. One of them is the static UPS system, which is being used in many data centers all across the world. And this basically consists out of two or even more cabinets. Inside one cabinet, there is a switchboard, and there are some control logics installed, and some levers and some breakers. And inside the second cabinet, or many of the other cabinets as well, the batteries will be installed. We have many different types of batteries that we talk about in the CDCP as well. They all have their own pros and cons. It depends on your initial investment. It depends on your ambient temperature, on the lifetime, the life cycle of your batteries as well. Which system you should be applying for your business. Now, obviously, we can always discuss how much energy should we keep inside our batteries how much time do we need to have autonomy time in order to run on the UPS batteries before the diesel generator kicks in. And this depends a little bit on the design and the application of your data center as well. An alternative for the static UPS systems could be a dynamic UPS system, also called a DOPS or a drops unit, which basically consists out of a diesel engine, an alternator and dynamo being the generator, and also a flywheel. And the flywheel is continuously running. And by keeping it on its nominal RPM, it will provide a certain small period of time of power. To give you an idea about that, static UPS systems in many cases is capable of providing up to 15 minutes of power to your IT equipment, which is long enough for the diesel generator to kick in. Now, a dynamic UPS system, the flywheel, quite often only has about 12 seconds of power. So you can imagine that the diesel engine will kick in without 1 second and then be able to provide power back to your IT equipment. Both have pros and cons. It depends again on investment, on TCO, on application, everything. And this is something that we talk about in the CDCP as well. Now, some of the slides talk about magnetic fields, electromagnetic fields, which is very important because in many data centers, EMF is not being taken into consideration. Now, electrical magnetic fields are present when you start operating your data center, but one of the two fields will increase by the time that you add more and more IT equipment and when you start to consume more power. Now, the more power you consume, the higher that particular field will become, and that might cause impact to your IT equipment or to your body as well. So don't underestimate the amount of EMF. It's wise to check your EMF radiation levels at a certain particular interval, maybe once a year, and to see how you can decrease the amount of EMF. Now, as we can see in this slide, if we apply shielded twisted pair networking cabling, then it will not provide against EMF. Many people think they do, but the standard shielded twisted pair cable does not protect against EMF, only alien crosstalking. Now, there are many different solutions how to decrease the risk of EMF, and this is something that we talk about in detail in the CDCP as well. Some are quite easy, and some are costing a lot more money. But doing the EMF review, doing the data center design is very important. Now, we talk about the many different racks in the CDCP. We talk about 2-post racks, which is the left rack, but we also talk about 4-post racks, which is the right one that we see in many data centers nowadays. In this case, the doors are made of safety glass, maybe, and this is not something that we see a whole lot, but nowadays we see many doors being either perforated or mesh doors, so we can get a higher cooling capacity at that particular server rack. So this is something that changed in the past 20 years. The type of cooling changed, and this is something that we talk about in the CDCP as well, but also the type of server racks that are being used. And obviously, we have them in many different types. We have them in all kinds of colors. We have them in different whites. We have them in different depths, different dimensions, different strength as well. And obviously, this all depends on your application. Now, the principle of raised floor design, this is something that we talk about in the CDCP as well, because many data centers all across the world are using a raised floor design. And in some countries, or in some parts of some countries, we also see that nowadays some designs are being made without applying a raised floor system. So in that case, the whole design is different, and then the cooling can no longer be distributed from underneath the raised floor, but it needs to be distributed inside the room itself. The pros and the cons between the two different systems, the raised floor design system and the, well, basically no raised floor design system, are being discussed and being displayed in the CDCP as well. And there are some interesting facts in this slide as well, because if you look at the position of the AC system, then obviously this is in line with the server racks. So this is quite important. Now for the cooling, we have many different types as well. In this case, we have overhead duct systems where we can apply extra cooling capacity inside corridors or aisles. In this case, in this example, you see that the cold air is being dropped from the ceiling and the hot air is being released through the ducts connected, hanging on the ceiling as well. And there are many different types to apply, many different systems to apply in order to get more cooling capacity. And think about the data center that's being retrofitted in the past, well, maybe 5 years or 2 years or 20 years, then cooling might become an issue. And if cooling is becoming an issue, then there are several systems available on the market that you can apply in order to get more cooling capacity at a particular rack spot. So the overhead ducts obviously need to be well designed. Think about the amount of air, because if you have too little air, then obviously the temperature is not leading anymore. If you don't have enough air, then it might cause hotspots as well. And also redundancy, because if we are going to apply anything such as an overhead duct system, and if the overhead duct is being serviced or maintained, or maybe it's not working anymore, then the redundancy must be taken into consideration, because this might have a huge impact on the available cooling capacity inside that particular aisle. So for the rear door heat exchanger, this is a rack which has a rear door heat exchanger. This is one of the systems that can be applied inside your server room as well. There are several different systems, but in this case, you could think that this kind of rack can be applied in a server room which is not necessarily that big. So a fairly small server room. And then the cold air that's being provided in front of your servers is being pulled through the IT equipment, so it's heating up, and before it's being released from the server cabinet, it's running through a rear door heat exchanger, and then it will be released as being cold air again, which can be reused at the intake of your IT equipment as well. Now, if you look at the small lines, it's a blue line and a red line. Obviously, these heat exchangers need to be connected to some kind of cooling system as well. This could be a chiller, for example, and then it would mean that there's water running through that heat exchanger. Now, as long as everything stays whole, then this is good. But if the heat exchanger starts leaking, for example, and this could only be a small leak or a huge leak, then we might have some water damage as well. So water leak detection is definitely key when you're going to apply such systems. Again, there are many different systems available on the market. This is just one example, and the other ones will be explained and will be displayed in the CDCP course. Now, do we have a hot aisle or cold aisle containment? That depends a little bit on mainly construction of the building, because originally many data centers are being designed with a raised floor system and a cold aisle contained area. So this is quite easy to implement in many cases, and by containing the cold or the hot aisle, it would mean that your efficiency level goes sky high. This will improve your efficiency a lot. Now, it does not necessarily have a big difference whether you are going to apply a hot aisle contained area or a cold aisle contained area, as long as the cold and the hot airflow keep separated as much as possible. And this will create your high efficiency. This mainly depends on the construction of the building, but also the type of cooling system that you're using, and whether this is an AC DX system, direct expansion system, or a chilled water system, or a system with a water tower. And all these different systems will be discussed, will be displayed and explained inside the CDCP 2-day course as well. So this is quite comprehensive. Now, we have a big chapter in the CDCP talking about the cabling system. The structured versus on-demand system is one of the slides where we have to figure out what are we going to do. Now, you can imagine that if you just sign up for your job and your main distribution area looks like the one at the left picture, well, you have quite a challenge coming up, because this will definitely take you a lot of time, but also a lot of stress to get it organized, such as the system that you see in the right picture. Now, they both have their pros and cons, either using structured cabling or on-demand cabling. This depends on your business, it depends on your initial investment, but also whether you know what type of bandwidth will be used in the next 5 or 10 years or so. So if you operate a data center for an enterprise, for example, you have a more solid, detailed information about the technical systems being used, so you might be able to apply structured cabling easier. Now, if you have a co-location system, data center, then obviously you don't know what type of IT equipment will be installed tomorrow or next month or next year. And then in many cases, on-demand cabling systems are being adopted. Now, you can also do a mix, like a hybrid system, because structured cabling is often being applied when you have to install a connection between 2 different server floors or server rooms, for example, from patch panel to patch panel. And then from there on, from patch panel to user, from patch panel to switch, for example, you can apply on-demand cabling. And then you have many different cables for that, obviously. You think about Cat5e, Cat6, Cat7, fiber optic, single mode, multi-mode, all kind of different connectors. This will all be explained in much detail in the CDCP. Now, for the sake of redundancy, we have to cross-connect all the different systems to each other as well. This is an example that you can see here. The network diversity and redundancy is definitely key. So in case one particular path or component fails in this setup, it might not necessarily hurt your company that much or not at all. So you can imagine that if you only have one fiber uplink cabling and the cable gets cut, for example, during maintenance works or whatsoever, construction works, then obviously the data center will become unavailable. So if we set it up with a redundant router just like this, redundant switches and routers, then the risk of downtime is fairly small. And there's a big chapter. This is a big chapter in the CDCP, which is also referring to the TIA, the Telecommunication Infrastructure Standard for data centers, which gives you many detailed information about setting up a properly designed network, and also to keep it nice and clean during the usage. Now, another important thing about running the data center obviously is fire detection and fire suppression. This is a fairly big chapter in the CDCP, and part of the chapter talks about the detection, such as these systems, the sprinkler systems, which is being applied in many data centers all across the world. Not necessarily because we like water near our IT equipment, but in many cases it's just mandatory by law, or maybe because of the insurance company. Now, this is a slow system because in general these systems will only be triggered when the ambient temperature around that nozzle will become 70 degrees Celsius or more. So in case of 70 degrees Celsius, basically the sprinkler will start throwing out water, and that's quite a lot of water. We also have the concealed systems, as you can see at the bottom, and these concealed systems will basically pop out of your ceiling or your concealed ceiling at an ambient temperature of about 57 degrees Celsius, and it will only start releasing water when the ambient temperature reaches a level of 70 degrees Celsius. Now again, this could be required by law, or mandatory for example, but we prefer to use different systems inside our IT environment. And one of these systems is called a VESTA system or an HSSD system. And this is something that we explain in the CDCP, which is a very good system. It's very sensitive, but also very reliable. And these systems can actually trigger your gas fire extinguishing system as well. And in the CDCP, we talk about 5 different systems containing gas in order to basically kill the fire. And one of those systems is called the NOVEC 1230 system. Maybe you know it from white papers or from articles at the internet. This is a very reliable system. It has some pros. It only has, well, maybe 1 or 2 cons, but compared to the other ones, this is definitely a winner. We talk about the pros and the cons of the system. It's a clear gas, which is very good. It's quite easy to refill, but it's not necessarily very cheap. It depends on the size of your data center. If you have a data center which is, let's say, 1,500 square meters or bigger, or maybe even 1,000 square meters and bigger, then another system could be preferred. And this is something that we talk again in the CDCP. Now, water leak detection definitely is very important inside the data center as well, because it could be the case that our cooling systems are containing water or maybe water glycol mixture. And in case part of this system starts leaking, then we need to be sure that the leakage is being detected and that a signal is being sent to our building monitoring system or our site engineer, so the leakage can be checked and can be repaired as soon as possible. Because in many cooling systems, water is being used. We'll also think about sewage. If we have any restrooms installed on top of our data center, in case we have our data center floor inside the basement, for example, then there's always a fair risk for water leakage as well. Also think about outside influences like rainwater. If we have any rainwater coming through the roof or through the rooftops, and the sewage or the drainage system is not working properly, then it could create water leakage inside the data center as well. And we definitely don't want to have any water near our IT equipment or any equipment which carrying power. Now, security needs to be applied at 3 different layers for the data center. One of the layers is the physical security, and the other ones will be discussed in the CDCP course. And based on physical security, in many cases, we obviously apply CCTV or IPTV cameras. Now, we can also apply fencing or walls or security guards. Depends a little bit on the size of your company and also the importance of your data center, obviously. And these CCTV cameras in this slide, they must be of a certain specification as well. They have a certain minimum specification that need to be applied, and then they are fit for purpose. Now, obviously, the recording needs to be taken place, and we could decide whether to install or to record the footage inside our server room, near the security office maybe, or maybe at a third party or at a remote location. And in case something happens, that we still have the footage. This is a fairly big chapter in the CDCP as well. And again, we talk about 3 different layers of security, and one of them is physical security. Now, one of the final chapters in the CDCP, right before the exam, would be the cleaning of the data center. How do we clean the data center? And do we use a bucket full of water and just splash it over the floor? No, most probably not, for the risk of IT power to shut down, or maybe even power electrocution. That's definitely not key. So in many cases, we can basically sign in for a dedicated company, or we have the do-it-yourself principle. And every time when we walk on top of our data center, we need to be sure that if we see any plastics lying around, or any zip ties, or any other debris or contamination, we should be picking it up and take it off the data center. Because dust is, in many data centers, a huge enemy. So it's very important to keep all dust outside of your data center, and cleaning needs to be done in a regular interval. Now, if you have dark color racks, like black racks, for example, it's quite easy to see the dust lying on top of the roofs of the racks, but it's very difficult to keep it out of your data center. Also, the filters need to be cleaned, obviously, every now and then. And as you can see in this slide, that too much dust is an indication of a leaking data center. So we talk a little bit about pressure levels inside the data center as well. And if we operate a data center and the pressure is at a certain level, then it will prevent dust from entering the server room as well. Now, the professional cleaners are key, because if during cleaning the reset button or the EPO button is being pressed in accidentally, because the company doesn't know that's very important, or that it should not be touched, then this could create downtime for your data center as well. So be careful by selecting external party to clean your data center. Instruct them very well. This is key. So this was a small part of the CDCP. Obviously, the CDCP course is a 2-day course. It's about 400 different slides, 400 pages. So it's very comprehensive, it's very overall, and it's definitely a very, very interesting course, because it talks about many aspects of running the data center. So both IT level-wise as facility level. And obviously those 2 teams need to work with each other. Now, let me get back to that in about 2 or 3 minutes or so. Because in this slide you can see that EPI released the DCPT, the Data Center Career Planning Tool, last year. And the DCPT can be accessed through the website of EPI. I'll provide you with a link after this course. And this is very interesting. Because if you can see that we can see on the slide as well, a bit of the background, the data center operator and employees frequently ask our consultants for examples of job descriptions, because what's involved with being a site engineer, or what's involved with being a site manager, for example. Now, the DCPT gives you a very good overview about the competences that you need to have for your current job, but also maybe for the job that you want to grow to. So this is a very solid document. It's very comprehensive. You can download it for free. It's a web-based tool basically, and it will actually show you which competencies you need to have for your current job and which competence you need to learn in order to grow to a different job. And obviously, it's easy to use to see which courses of EPI are interesting for you and for your own development as well. Now, as we can see over here, there was guidance available to data center operators indicating what skills, knowledge, and competences are required to design, build, operate, and maintain a data center. Now let's have a look because the challenge is which training should we follow for the EPI? Well, by applying for the DCPT, again, this is a free tool. It will give you a good overview of which training you fits for your job description, basically. It will create a data center career plan for you. This is a personalized career plan, so you can see which competence should be learned, and you can sign up for these courses as well. Now, it provides details for required training and to meet the competence levels, and it can also create as a good tool for your HR manager, for example, to request some budget to train yourself to basically the next level, to get proof of your knowledge as well. Because sometimes it can be hard to get a budget, and if you sign in for the DCPT, this could definitely help you out a little bit. I have to speed it up a little bit because I have about 3 minutes left for the course for the sneak peek. So again, if you sign up for the DCPT, it will also include an appendix from the DCCF, the Data Center Competence Framework, which can be found on our website as well. And it will tell you again which training could be interesting for you in order to expand your knowledge and also to confirm it. Now, how can you use the DCPT? You can find it on our website, www.epi-ap.com/DCPT. If you surf to this link, you can fill in your name, you can fill in your email address, and then everything goes from there. This is a free tool. Or you can go to our main website, epi-ap.com. Again, before this sneak peek closes, I can basically answer some of your questions, but because, for the sake of time, I would advise you to send me an email at marco@epi-ap.com with any questions that you have about the CDCP or any of the other EPI courses. Then we have some time to answer to your questions accordingly. Now have a look at our website, www.epi-ap.com, and again feel free to ask me any questions by email. You can if you have any questions right now, you can put them in the question screen as well, but the time for this Bright Talk session is almost done. So does any of you have any questions? In that case, again, feel free to send me an email or to send any of my colleagues an email at sales@epi-ap.com or marco@epi-ap.com. I want to thank you very much for your time, for your interest, and hope to see you in one of the next CDCP classes. We provide those classes. It's a 2-day class. We provide them in a classroom, but also virtually. So you can basically attend the classes from anywhere in the world. And we have a schedule listed at our website, www.epi-ap.com. Thank you very much. And again, feel free to send me an email about any of our courses or anything regarding this CDCP sneak peek. Thank you very much.